All right, good morning. Hope everybody is doing well. So yeah, when I teach in person, I always wear a suit every day, and most of you, maybe got to know me in spring through 250, and then you've known me this quarter, and it's all been online, so I haven't been dressing up. So I thought I would dress up for the last day of class, just to kind of do the tradition. Um, So yeah, this is the end of CSE224, last lecture, and that's pretty cool. So this has been a lot of stuff that we've gone over. It's been a lot of work on your part, and I just want to say, thank you to everybody for your attention and your energy and your hard work, and I think it will all pay off. I think everyone is in good shape for 222 and for building on this beyond Clark. So it's been a pleasure working with all of you. And if you're doing the 200 sequence, I'll see you in winter for 222. So my basic goal for today was to do a quick review for the final exam. But any questions or comments up front, anything you want to talk about, we can definitely go through that first. I posted a rough study guide on Canvas, and I'm really just planning to kind of talk through it today. So anything you want to go over in particular, we can start with that. So the test will be a Canvas quiz. It will pop up Wednesday at 11 o'clock. On Canvas, you'll have 2 hours to complete it. And it will be a combination of essay questions that you type code into, right, or type somewhere and paste. But there'll also be some short answer, multiple choice, matching, fill in the blank kind of questions that you'll just do as a regular Canvas quiz. It will be 3 programming assignments, 1 in C, 2 in Bash, and that'll be 60 points, and then there'll be 40 points, probably 7 or 8 short answer type questions. Yeah, I did lose my audio. Give me 1 sec. There we go. All right, other questions? Where in Canvas are the posts? How do we navigate to it? So if you it should just be under the announcements. But let me double check. This is always a little tricky in Canvas, trying to make sure I'm seeing what students are seeing. But anyway, that should be your student view. So, Bash summary up there. And then possible exam topics down here. And that's what we're going to go through. So there's a placeholder for the final exam here that will be replaced by an actual Canvas quiz. This will go away, and you'll see a quiz, but that won't open until the exam time. So the exam starts at 11 o'clock. It is not just when you're ready. It is not an all-day exam. It's precisely from 11 o'clock to 12:50. So that's important. All right. Hopefully it's not going to take, the full hour and 50 minutes. I'll give you 2 hours for this, okay? But at 2 hours, right, at 1 o'clock, Canvas will shut down. And if you haven't submitted by then, right, then you don't get a chance to submit. So take this as being, the duration of the exam, and leave yourself, a few minutes at the end if there's a submission problem, if you try to submit and suddenly your machine reboots or something like that, right? And as before, right, I suggest writing your code up, in an outside editor, and then pasting it into Canvas rather than trying to type directly into Canvas, because Canvas sometimes, does funny things. And it's open book, open note, got to work on your own. Everything you turn in has to be your own work, etc., etc., and you're not allowed to use, a compiler or things like that. Basically just your notes, your book, and yourself. All right, so this is the document I posted in Canvas that just kind of hits, the major things that we've been doing for the past 11 weeks now. Shouldn't be any surprises in here, so we'll just go through this sequentially, but ask questions along the way if you want more detail, etc. So basic Unix commands, there should be nothing to really study here. If you've been working on the command line and you've been in a Unix environment for 11 weeks, writing your programs, pulling down ODPs, pushing code around using Git, you should know all of this stuff, right? There shouldn't be a whole lot to figure out or to practice. You don't have to memorize because you have notes. So yeah, what is echo? So echo, cat, copy, move for renaming, rm to remove, ls, putting switches on some of these commands like ls-l. We didn't really do a lot with od. Od is an octal dump. It's just a way to look at non-printable characters. xxd is the same thing. WC for word count, right? Number of lines, words, and letters in a file, or standard in. Date for seeing the date. Cause, I forgot to put cause on there. Most important command in all of Linux, followed by SL. So know those. I could ask you a question with moving files or something like that. So for Git, very specific commands I want you to know. Well, thank you. Very specific commands to know for Git. You should know how to do git init to create an initial repository, and you should know that we only do that once per repository. You don't do that every time you change a file or make a new file. It basically sets up, the whole Git structure for a project. So you do git init once, but then every time that you have a change that you want to save, git add, git commit. Change a file, git add, git commit, right? Or change a bunch of things and then do git add, git commit. But that's how you take new versions of files or new files and push them into the repository. These are all local. This is on your laptop or whatever machine you happen to be running on. If you want to also copy your repository to a remote site like GitLab, right? You do a one-time setup, git remote add origin, git at gitlab.com, username / repo.git. You've done this, at least several times for your projects. That sets up the linkage between your local repository and a remote repository. And then git remote push origin, git push origin master takes your local repository, pushes it out. So you should know those five versions of Git commands, and you know the basic concept of Git, right? Having tracking of past versions of code and being able to restore past versions and et cetera, et cetera. There's obviously a lot more to Git. There's more to Git that you might already be using, but as you know, single developers, just you know, working locally and pushing out to a server, you know, as either backup or to submit code. Those are the 5 commands we need. All right, standard in, standard out, standard error. Those are our 3 streams that are always available. They permeate Linux. They permeate our code. When you do fget standard in, you're reading from standard in. When you do printf, you're printing to standard out. When you run a command, it reads from standard in. Usually it produces output to standard out. If you say gcc and it produces error messages, those go to standard error, which looks like the same as standard out usually. But we can change what the meaning of standard in or standard out are by using these redirections. So if we say command greater than and we put in a file name, hold on a sec. Thank you. I have so many goodies coming in the mail today. If you say command greater than file name, then standard out is sent into that file, right? So it zeroes out the file and then writes everything that goes to standard out into that file. If you say command less than file name, standard in is read from that file, and it opens the file, starts reading the first line, and each line that it reads is fed to standard in, and then when it gets to the end of the line, it signals end of file. So it's like hitting a Control D. So those are redirecting output and input, and then greater redirects output, but also appends to the file instead of zeroing it out. All right, we can also change standard in, standard out by using pipes. And so our typical structure is, you know, some command C1 pipe, some other command C2. And the idea is standard out of C1 and standard in of C2. Those are connected now through a pipe. And so what do? We do something like, you know, who, to see who's logged into the system. We can pipe that into WC to say count the number of lines on standard in. Well, standard in is coming from standard out of who, so this tells us how many people are logged onto the system. Or maybe we do who and we pipe it into sort and we pipe it into unique to get rid of multiple occurrences of the same name. We pipe that into word count to see unique users. And then maybe we pipe that into awk and print $1 to see the first field, which is the number of lines, which would actually be the number of users. And then maybe we put that whole thing inside back quotes so we can set a variable equal to the result. So those kinds of gymnastics in bash, right, you should be familiar with. All right, so quotation marks. Double quotes are used to take something that might have spaces in it, for example, and treat it as a single thing. For example, if I say x equals hello there, it's going to complain at me, right? Because it thinks there is supposed to be a command. So what can I do? I can put this inside quotation marks, and now it treats, you know, hello space there as a single thing. Double quotes are useful, but they still will do things like $ replacements. So if I have a $x, that means show me the value of the variable x. This will get replaced with the value of x, even though the whole thing is inside double quotes. But if I use single quotes, then this string would just be, you know, a bunch of stuff with a $ and an x in the middle of it. All right, so both of those group things together, but single quotes basically just turn the whole string into a literal. Double quotes still allow dollar signs to be expanded. They allow back quotes to be expanded, and so on. And back quotes are this totally different structure like this. So if I say back quote command, this string in here is actually taken as the name of a command which is executed. And the result of that command, everything that's sent to standard out, is used as the value of this back quoted string. So yeah, backticks. And so if I say variable equal back quote, some command, it replaces that variable with the value of the command. So, x equals back quote date sets x equal to the current date. X equals single quote date sets x equal to date. X equals double quote date sets x equal to date. So the backticks are really magic. If it's called a backtick, what is a forward tick? It's like an analog watch. Can you use a combination of backticks and quotes for a single variable? So yeah, I could say something like, x equals quote, the date is back quote date. And that's totally legit. All right, so play around with those if you're not familiar with them, but we've used them a lot. We especially used the back quotes when we were playing around with dialogue, right? And we were capturing output from that command. And that should not work inside single quotes. So if I do single quotes, I should just get a literal string. Alright, so single quotes are really just make this thing literal. You could probably write a book on quotes in Bash, though, because there's lots of weird cases in there. I'm not going to get into any weird cases on you. We'll keep it pretty straight. All right. So you should know about shells, right? So what is a shell? It's a program that basically interprets your commands that you type. We use the bash shell, or the shell called bash. And mostly, you type something in, and it either treats that as a built-in command, like, x equals hello, or it takes it as the name of a program that you want to run. And it searches for a program with the same name, and it executes it. There's a bash RC file. It starts with a period. It contains commands that we can use to initialize the behavior of our bash session. So, this happens to be my bash RC, which mostly, sets up aliases for me, sets my mouse sensitivity, stuff like that. Sets up a path so that I can find things in certain libraries and so on and so forth. So number sign exclamation mark is a shebang, right? We'll talk about that when we get to scripts. Aliases. So aliases are a way to set one command equal to something else. And I just had, a really good example of aliases in here. So, alias command equals, and then what you want that command to be equal to. So if I say ldec, it automatically does cd into this big, long, horrifying directory that I don't want to type in by hand, right? Or more importantly, if I say Minecraft, it goes ahead and it runs my Minecraft launcher with an ampersand to run it in the background. So aliases just let us, set up one symbol to mean something else. So basic shell stuff. Processes. All right, so when we type in a command, we can put an ampersand at the end, and that will say run the command in the background. So it's running in parallel with the bash shell. Your bash shell comes back, waits for you to type stuff, but your command is still running in the background. If you run a command by just typing the command name and hitting enter, right, your bash shell is basically like hanging out in the background waiting for your program to finish. If you hit a Control Z, that will suspend your program, bring you back to your bash prompt, but it doesn't kill your program. It's stopped, and you can tell it to start running in the background by saying BG. So Command Control Z BG is basically the same thing as Command ampersand. Right? It runs it in the background. If you have a job in the background, you can say FG and bring it into the foreground. You can say jobs to list all the jobs that you have either stopped or running in the background. You can say kill and put in the job ID, the process ID, or you can say kill %, the number of the job that you got from jobs, all that stuff, right? So high-level concepts here, right? And then PS is a command you can use to look at processes that are running on the system. Zillions of switches available for that. Don't worry about them, right? Again, just basic concepts. All right, fork. What does it do? It creates a clone of your current process. What does it return? It returns either a 0, which tells you that you are the clone, or it returns something non-zero, which tells you you're the original. And the value it gave you back is the process ID of the clone. All right, that's all I need you to know about fork. It creates a clone of the process, and it returns either a 0 or the process ID of the clone. And then more general concepts, right? Once you forked, what we usually want to do is turn the clone into another process, and we do that with some kind of exec function call. I'm not going to ask you to write code using exec or to know about the arguments to it or the different types of it, but just know that there is this function, execl, something like that, that will take the current process and change it into a process that's running the code from another file. And if the two of these are really, the things that go together into making a new process, make a clone with fork and then specialize it using exec. Let's see, so we aren't really going into some of the stuff in depth that we've been talking about this week. You mean as far as processes? So we're not going to worry about pipes or popen or dupe to or arguments to exec or things like that. We're not going into that level of detail. But high level concept, there could be, matching questions, and one of the things would be fork, and you would match it to, creates a clone of the current process, something like that. Or, questions like that. All right, file system concepts. So, remember, there's a hierarchy of files in the system, and they're rooted at /, and there's subdirectories under there. So there's a /home, and under /home there's a /home/nic, and under /home/nic I've got a /224 directory, right? And there's there's also home, nic, tools, and so on, right? So it's like a tree-like structure. And there's always two directories that are available to you. There's period, which is your current directory, and there's two periods, which is your parent directory. And so wherever you are in your directory structure, you can always bump up one level by saying like change directory to ... Or if you want to know about your current directory, you can just refer to it as dots, so you don't have to know, for example, that you're in this directory. So there's ... and ... cd lets you change to a directory. cd without any arguments changes to your home directory. pwd shows you your current directory. Hidden files are files that begin with a period in the first character of their file name, and they're no different from any other file. The only difference is the ls command by default doesn't show you files that begin with a period. So they're called hidden files, but they're really just like any other file. But we've got these files like .bashrc, .vimrc, .git, .gitignore that are in our directories, but we don't really want to see them every time we say ls. So ls was written with this default behavior of not showing those files. If you want to see them, do ls-a. Alright, there's permissions associated with files, and there's basically 3 categories. So someone pointed out last time, this is technically called user, this is called group, and this is called other. Although I learned it as owner, group, and world. But basically, this is the person who owns the file. These are people who are in the same group as the file, and this is everybody else in the world. And these bits basically tell you whether you can read, modify, or execute the file. And each of these is a binary, 1 or a 0, and if you write this out as a 3-digit octal number, you get an argument you can use for change mod. So, you know, if I said change mod 550 file, it would make that file readable and executable by myself, people in the group, and no access to anybody else. So change mod and permission bits. Let's see, can you do cd ... folder where folder is in the previous folder? Yeah, definitely. So, right, so here's my directory. I can say current ... /fall 2014, and I've moved up, over, and back down. Right, I can say go up and then go up again and then go down to material. So I've moved up twice, moved over, and gone down. If I'm in slash and I say go up 1 level, I just stay in slash. You can't move above the root. If I cd to dot, I'm always going to stay in my current directory, because dot means your current directory. Alright, setting variables to a value, so we can say variable name equals whatever, and it will set that variable equal to whatever. And if it's just something like hello or 2 plus 3, it will set x equal to HELLO or 2 plus sign 3. It's a very literal kind of assignment. And remember, in bash, spaces are really, really finicky. So if I say x space equals space hello, it will complain, right? It will have no idea what I'm talking about. So you got to do it with no spaces. All right. So you've encountered this, right? We've all gone through the trials and turmoil of using bash. If I want to do arithmetic, right, I can do x equals $paren, and then put an expression inside. And I can have variable names in here. If I want, you know, the argument $2, I have to say $2. It's not going to take 2 to mean $2. But if I were to put an x in here, it would use the value of the variable x. So this kind of turns it into a sort of normal, reasonable looking arithmetic expression. All right, we mentioned exporting variables. That's not a big deal, but basically all these assignments are local. So if I create a new subshell, these assignments are lost, right? If I set x equal to hello and then I run a script, inside that script, x is not defined. If I want that value to be global, if I want it to be exported to all things that are created, all scripts and shells, I can say export in the name of the variable. All right, so don't worry too much about that. Definitely worry about the built-in variables though. So when you run a script, you can put command line arguments on it next to the name of the script. You can pick those up as $1, $2, $3, and so on. $number tells you how many arguments you have. $question mark shows you the status of the previous command that you ran. Right? And remember, it's always the most immediate previous command. So if I say echo $question mark, it shows me 127 because my previous command had an error. If I echo $question mark again, it shows me 0 because my previous command, which was this, did not have an error. Right? So it's always the result of the previous command's exit value. All right, $$ just shows you your process ID. We don't really use that a lot, but it's cool to know. Dialog. All right, so we use dialog for making GUIs. You did a whole group project on this. I'm not going to ask you details about dialog. I'm not going to ask you to write a dialog. I'm not going to ask you, to construct a dialog that's, this dimension and this color and has this on the title and so on and so forth. But I want you to understand the basic concepts, right? I may show you a dialog command and ask you some questions about it. There could be conceptual questions. You should know basically that you can use dialog with switches to pop up GUIs, and you should know how to capture the output. Okay, by putting the whole command inside back quotes and having the, dash dash output dash FD, etc. at the end. But don't worry about details beyond that. All right, GCC. Have we talked about GCC yet in this course? So hopefully people know how to compile a C program. But you should also know the O switch, right? So -O takes whatever file name you put right after -O, it uses that as the name for the created executable. So GCC-O blah, other stuff, if it compiles and makes an executable program, that program will be called blah. -C says don't make an executable, just compile to an object module. So make a .o file. -G says, do everything else the way that it normally would be done, but leave some information in my file so that I can use GDB to do debugging. And -LM is an example of something we would put at the end of a GCC command, in this case to link in the math library. So if we're doing square roots or sines or logs and we need something from the math library, we would say -LM at the end of the GCC command. All right, GDB, the debugger. So you should know basic details about using GDB. So what should you know? Use -G to compile with debugging. Use GDB space program name to execute. So let me just go ahead and do this. So, this is a sidebar here. Can't open file for writing, right? Why? Because I'm sitting in a bad directory. So :!print working directory. I'm in my / directory. All right. So I'm going to write this into my home directory instead. So I'll compile go.c with the -G switch for debugging. So now if I want to debug, what do I do? GDB and the name of the program. All right. I can say list to list my program. I can say break to put a breakpoint somewhere, like line 6. I can say start, and it always stops in the very beginning, so I can say continue, and continue will run until I hit a breakpoint. And once I hit a breakpoint, I can print the values of my variables. K has not been initialized yet, so it happens to have a 0. Okay, once you're running your program, you can step or next to execute another instruction. So I can say next, and this will do the K equals I times J, so now when I print K, it's equal to 6. Step and next are basically a step into and a step over if you've done 270. Step will go into a function if your next instruction is a function call. Next will skip over that function. It will execute all the stuff in the function and then come back to the debugger. But the basic setup is, right, we can use this to run our code in a controlled way and see what's going on while it's executing. So we can look at variables, we can examine memory, we can print, not just variables, but things like, print the address of a variable. We can examine memory locations. and so on and so forth. I'm a little disturbed that that's a 32-bit address. All right, so GDB, basic concepts and commands for that. Make files, definitely know how to make a makefile. Know what a makefile does, and make sure you understand this beyond, you know, a 2-line makefile that just compiles everything and builds an executable in one command, right? We want what I've been calling a good makefile, so something that very deliberately compiles just the stuff that needs to be recompiled when you change a file, for example. Plus, you know, maybe having a make clean to get rid of other stuff. So I might ask you to create a makefile. I might show you a makefile and ask you questions about it, or ask you to make changes to it, or something like that. And then make, you know, is the command that says look at the makefile and do some stuff. Regular expressions, we've used these throughout the quarter. You use them for homework 8. You've used them for other things, and we've been working with them a lot yesterday. So if you knew how to do everything that we were doing yesterday, you got a pretty good idea about it. You should be fine with regular expressions. Basically, you know, matching patterns, anchoring expressions to the beginning or end, using registers for simple replacement. I won't ask you anything more complex than what we worked through yesterday, so don't get too concerned with these. But, you know, either writing regular expressions or showing me what a regular expression does to a string, something like that. Sed, mostly we use it for doing a regex on a file, line by line, but you know, there's other things we can do in there. I'm not going to ask you to write sed programs. I'm not going to give you a big long sed program and ask you questions about it. But just know, you know, that it can do things like, you know, delete lines, print lines, match patterns on lines, things like that. Awk, mostly use it to print out fields from each line, you know, print $1, etc. Again, I won't give you big long programs or ask you to write programs, but you should know, you know, the basic things that it can do. Bash programming, so shebangs, comments, ways of accessing command line arguments, getting the return status from prior commands, doing assignments. If statements, I'm still going to be dogmatic about this, so to get full credit, your if statements have to look like this. If space, bracket, bracket, space, condition, space, bracket, bracket, new line then, body of the if, and then either a fee or another elif, the same structure, or an else statement. All right. And your condition should have one of two forms. If you're comparing strings, you know, something equals something, or maybe something not equal to something. If you're comparing numbers, you've got to use -eq, -ne, greater than, etc. Any of those 6 comparisons. All right. I didn't actually freeze. I'm still here. There we go. So yeah, stick to that style for if statements. Never, ever, ever, ever use single brackets for 224. Okay, that's the easiest way to keep it straight. And if you go to Canvas, there's that thing in the front which is, you know, how to write bash statements. That will show you all of the accepted syntax. And for an if statement, this is the only thing that I'll accept. Wow, I'm lagging. So don't ever use single brackets, right? You can once you're outside of 224, but just, you know, for another 5 days, stick to it like this. And then for while loops, same thing. While space, bracket, bracket, space, condition, space, bracket, bracket, new line, do, body of the while loop, and then done. And the conditions follow the same rules as they did for if. Single brackets are really funny in Bash. They're actually a function, which is kind of strange. So yeah, we'll just stick with doubles for here. Let's see. So no for loops in Bash programs for another 5 days. Once we're done with 224, go crazy with for loops if you like, but I'm not going to let you do for loops with the for keyword in bash programs, right? So that lets us stick to double brackets and not use parentheses and so on and so forth. Variable assignments we talked about, backticks, things like that, $paren we talked about. Read and echo are our main ways to do input and output, and think about algorithms, right? So mostly, you know, you have to know the mechanics and you have to know the syntax, but I also want you to be able to come up with algorithms and write code, you know, to do certain things. And, you know, think about the kinds of things we've been doing. Think about the ODPs. Maybe the ODPs we've written in C, try to write those in bash or vice versa. Some of that would be really hard, but, you know, make yourself some sample programs. Simple things, right? Basic procedural stuff. If you've never looked at FizzBuzz, take a look at FizzBuzz. FizzBuzz is a trivial little program, right? It's a program that prints out numbers and then prints out the words fizz and buzz every now and then. And it's a classic interview question, and apparently, you know, greater than 90% of candidates interviewing for programming positions cannot write FizzBuzz during an interview. And it's so you can find, you know, what this is online. Just Google it and read some horror stories while you're at it. But, you know, basic things like this don't need a lot of sophisticated algorithms, a lot of fancy mechanics and so on. It's basically, you know, looping and conditionals and putting steps together in the right order to do some algorithm. So that's a kind of good example to think about. All right, and then C programming. So a lot of this is similar to what we've already said. So basic syntax, assignments, declarations, ifs, fors, whiles, and so on. You're okay using for loops in C, okay? I'm only funny about it in bash. But in C, go ahead and use for loops if you like. Know the difference between declaring a variable and actually initializing it. So if I say integer I does not have a predefined value. If you want I to be 0, make sure you say I equals 0. All right. Characters, right? A character is a short int, and mostly in this course we worked with integers and characters. There's other types of variables. There's floats, doubles, etc. But mostly we work with integers and characters, and then arrays of those. Comments, know how to write comments. Put them in your code if you're unsure. If you're doing something right, put in a comment and tell me what you're trying to do. It can help for partial credit. Include statements. Know what an include statement does. Okay, the fact that it's basically pulling in code from a file. And if we use angle brackets or double quotes, it pulls in from different places accordingly. Arrays. So an array is what? It's a way to take a collection of data and basically access it with a single variable name. But in reality, an array is really just a memory address. It's telling us where something is stored in memory. We don't have to worry about that for the most part for this course, though, right? We can just say, you know, integer x bracket 10, and x is an array of 10 integers. And we can sort of treat it like that. One of the main ways we use arrays is character arrays. This is how we store a string, because there's no built-in string type in C. So an array of characters is a string, and remember, arrays are just, you know, stored sequentially in memory. Really important point, there's nothing in C that tells you how long an array is. So if you know this is an array of 10 integers, then you know not to go past, you know, the 10th element. But if you have a string of characters, how do you know how many characters make up that string? So we always put a 0 at the end of the string. If you want to store the string A, B, C, we'd store an A, a B, a C, and then we'd store a 0. And print and string compare and string length and all that, when they look at a string, as soon as they get to a 0, they say, oh, there's the end of the string. So it's a convention. So that's the null terminator. String length, string compare, two good functions to know. There's a few other ones from string.h. But those are the main ones we use, right? Number of characters in a string and comparing two strings. Because equal equal doesn't work for comparing two strings. Math.h, there's some libraries. Math.h for math functions, string.h for these string functions. C-type we haven't done a lot with, but if you want to do things like convert case or see if something is a digit and so on, ctype.h has the functions that you want to use. Alright, definitely know how to declare a main program with arguments and understand what argc and argv do. This will be one of your questions. You'll have a C programming question, 2 bash questions. Your C question will require you to deal with command line arguments. So make sure you understand argc, argv, and make sure you understand how to avoid a seg fault. Right? So if you run a program and you say something like, you know, my program 25, argc is equal to 2. And the first argument, the name of the program, is argv bracket 1. The second argument is argv bracket 0 and argv bracket 1. And if argc is 2, I better not do anything with argv bracket 2, or 3, or 4, or 5. So it's really important if you're going to deal with these arguments, before I look at argv bracket, you know, anything, check argc and make sure that argv bracket whatever actually exists. Alright, you'll definitely have to use scanf, so know how to use scanf, how to convert, you know, typically a string to an integer, and how to tell if that conversion succeeded, which is looking at the return value from the function call to scanf. And this usually goes together with, you know, using argc and argv. Printf is just, you know, how you do output. Fopen, fclose, fflush, fprintf, these are versions of doing I/O where we're working with a file instead of just standard in, standard out. So I can open a file on disk with fopen, I can write to it with fprintf, and so on. I can also read from it with fgets. But we use fgets normally to read from standard in, but we make that third argument standard in. Alright, but it's a general function for reading from a stream. So know how to use fgets and so on. Make sure you know what's wrong with gets and why we should not use gets, and don't use gets. And then functions, know how to write a function, how to pass arguments to a function, how to call a function, how to access the arguments inside a function, how to return values from functions, all that good sort of stuff. And then the last thing, again, just algorithms. Just make sure that you can think in terms of algorithms. Being able to you know, make a running sum, so initialize the sum to 0, and every time you get a piece of data, add it to that running sum. And when you're done, that variable will be the sum of all the numbers that you saw. Or using a flag to record some event as having happened so that you can use that information later. Classic example here, testing to see if a number's prime. So go through all the possible things that could divide it, and if something does divide it, set a flag. Right? When you're done with that set of tests, just check that flag. If it's been set, you know that something divided your number is not prime. Initializing things, doing loops, doing conditionals, right? All the basic stuff that goes into a programming language. That's pretty much it. So I'll see you in 2:15 in 40 minutes if you're in there. If not, have a good rest of the day, good weekend. Good luck with your other exams, and I will see you Wednesday, 11 o'clock for your final in here. All right, and thank you again. Have a good one. Bye.